Tonight, we are going to look at one of the most fragile and ambitious ideas in all of space exploration, the generation ship. A vessel so large it would not carry only astronauts, but families, children, farms, machines, schools, memories, and an entire human future inside its walls. It would not cross the distance between stars in days or years, or even in one lifetime. It would move slowly through the dark for generations, while the people who first boarded it grew old, disappeared, and left the mission to descendants who never chose to leave Earth at all. But how long could humans really survive inside a sealed world drifting through deep space? Could one ship keep its people alive for centuries with no resupply, no rescue, no sunlight from home, and no way to turn back? Could its air remain breathable, its water clean, its food stable, its machines working, and its society peaceful long enough to reach another star? Before we begin, take a moment to tell us in the comments what time it is where you are, and from which city or country you are watching tonight. And if you enjoy calm journeys through the universe, subscribe to Astro On Sleep, where we explore the mysteries of space slowly, quietly, and deeply. Now, let's begin. To understand how long humans could survive inside a generation ship, we first have to understand why such a ship would exist at all. Because a generation ship is not the first solution humanity would choose. It is not elegant. It is not fast. It is not the dream of space travel we usually imagine, where a crew launches from Earth, crosses the darkness, arrives at another world, and steps out under an alien sky within the same lifetime. A generation ship exists only because the universe is too large, and because almost every faster solution we have imagined still lives somewhere between theory, speculation, and hope. The nearest star system to our own is Alpha Centauri, with Proxima Centauri orbiting nearby as the closest known star beyond the Sun. Even that nearest neighbor is more than 4 light-years away. Light itself, moving faster than anything with mass can ever move, needs more than 4 years to cross that distance. A radio message sent from Earth today would not arrive there until years from now. And if someone there sent a reply, we would wait years again before hearing it. That is the closest star. Not the best destination, not the most Earth-like promise, just the nearest point of light outside the solar system. For a spacecraft, the problem becomes almost cruel. Voyager 1, one of the fastest objects humanity has ever sent outward, is still moving at a speed that feels enormous when compared to anything on Earth. It crosses hundreds of millions of miles each year. It left the planets behind. It entered interstellar space. It became the symbol of human reach. And yet, at that kind of speed, reaching even the nearest star would take tens of thousands of years. Not centuries, not a long mission, not even the lifetime of a civilization as we usually measure one. Tens of thousands of years. That single fact changes everything. It tells us that interstellar travel is not simply a matter of building a bigger rocket. It is not like crossing an ocean with a stronger ship, or crossing a continent with a faster train. The scale is different, in a way the human mind struggles to hold. A journey to another star is not just farther than anything we have done before. It is so far that our normal relationship with time begins to break down. The distance does not ask whether we are brave. It does not care whether we are curious. It does not move closer because we want it to. So the first question is not how humans survive inside the ship. The first question is how long the journey forces them to survive. If we imagine a future spacecraft capable of reaching 1% of the speed of light, that would already be astonishing. 1% of light speed is far beyond anything we can currently do with crude spacecraft. It would require energy, materials, propulsion, and safety systems on a scale we have not yet built. But even at that speed, the nearest star would still be hundreds of years away when you include acceleration, cruising, slowing down, and approaching safely. If the ship reached 5% of light speed, the journey could fall into something closer to a century. Still long, still beyond the life of many people aboard, still enough time for children to be born, grow old, and pass the mission to others. And that is the doorway into the generation ship. A normal spacecraft is built around a crew. A generation ship is built around continuity. It is not just a vehicle. It is a moving society. It must carry people who can live, work, age, reproduce, learn, teach, disagree, cooperate, repair, farm, govern, remember, and eventually hand everything to the next generation. It has to be a home, a school, a hospital, a factory, a farm, a power plant, a water system, a government, and a culture, all sealed inside one artificial world. The ship does not simply transport human beings. It must preserve the conditions that allow human beings to remain human. This is where the idea becomes much stranger than it first appears. Because when we say a generation ship needs to survive for 200 years, we are not only talking about metal lasting for 200 years, we are talking about trust lasting that long. We are talking about knowledge lasting that long. We are talking about discipline, meaning, cooperation, health, and purpose surviving long after the original crew is gone. The first passengers might understand the mission deeply. They might remember Earth. They might remember sunlight through real clouds, wine through trees, the sound of rain, the feeling of walking outside without thinking about pressure seals or air recyclers. But their children will know those things only as story. Their grandchildren may know them as history. And after enough generations, Earth becomes something more distant than home. It becomes an origin. That matters because the people who keep the ship alive in year 150 will not be the people who launched it. They will not have chosen the journey. They will be born inside it. Their world will be corridors, habitats, agricultural decks, artificial light, recycled air, controlled weather, if the ship is large enough to have any, and windows looking out into a darkness that barely changes. They will grow up with the knowledge that the ship is not a temporary place. It is not a station. It is not a mission they can finish and return from. It is the only world they have ever touched. So the survival of a generation ship begins with a difficult truth. The ship must be designed not only for the first crew, but for people who will inherit it without consent. That is a heavier challenge than propulsion. A rocket either works or it does not. A reactor either produces power or it fails. But a society can appear stable while slowly changing underneath the surface. A community can keep its routines while losing the meaning behind. A school can keep teaching procedures while slowly forgetting principles. A government can keep its structure while losing legitimacy in the eyes of people who feel trapped by decisions made long before they were born. These are not dramatic failures at first. They are quiet. They move slowly. And on a generation ship, quiet failures may be the most dangerous ones. But before we reach the human problems, we have to begin with the physical ones, because no society can survive if the machinery underneath it dies. The first requirement is power. Everything inside the ship depends on energy. The air must move. The water must be purified. The lights must shine over crops. Computers must run. Medical equipment must function. Pumps must push fluids through pipes. Heat must be moved from one place to another. Doors must seal. Sensors must measure pressure, oxygen, radiation, temperature, chemical balances, and structural stress. If the ship uses artificial gravity through rotation, the rotating sections must be monitored and maintained. If it uses propulsion or course correction, those systems need power too. On Earth, energy is everywhere around us. We are surrounded by systems that make it available. Power plants, grids, fuel supply chains, repair crews, mines, factories, transport networks. If something breaks, another part of civilization can help. A generation ship has none of that. Whatever it carries is what it has. Whatever breaks must be repaired from whatever fuel is needed must have been planned before launch. The ship cannot pull into a port. It cannot call for a replacement turbine or a new reactor component. It cannot wait for a shipment. It is alone. Solar power may help near a star, but deep between stars, sunlight becomes almost useless. The sun fades behind the ship, shrinking from the source of day into just another bright. The destination star is still too far ahead to provide meaningful energy. For most of the voyage, the ship must carry its own source of power. That probably means nuclear energy in some form. Fission is the most realistic near-term option. Fusion is more powerful and more attractive in theory, but remains difficult to master even on Earth, where engineers have laboratories, supply chains, and entire institutions around them. A generation ship would need reactors designed with extraordinary redundancy. Not one heart, but several. Not one control system, but backups. Not one group of specialists, but a continuous educational chain that trains new people before the old ones are gone. The reactor is not simply a machine. It becomes an institution, a sacred responsibility. Every generation must understand it well enough to operate it, inspect it, repair it, and recognize danger before danger becomes irreversible. And here the first deep problem appears. Machines can be maintained, but understanding has to be transferred. A manual is not enough. A database is not enough. A child can read the steps of a procedure and still not understand the system. A technician can memorize what buttons to press and still be helpless when a failure appears in a form nobody predicted. The ship needs people who understand why the system works, not only how to use it. It needs engineers who can think from first principles. It needs apprenticeships, schools, tests, simulations, and a culture that treats technical knowledge as survival, not as a career choice. If that culture weakens, the ship may still appear healthy for a while. The lights still turn on, the air still moves, the crops still grow. But beneath that surface, danger is accumulating. One generation cuts a training program because it feels too difficult. Another simplifies a maintenance ritual because nobody remembers why one step matters. Another trusts automation more than judgment. And then, decades later, a warning appears in a reactor system, and the people alive at that moment realize they know the procedure, but not the reason behind it. On Earth, that would be serious. On a generation ship, it could be the beginning of the end. After power comes air. Air feels simple because we live inside it so completely that we rarely notice it. But inside a sealed ship, air becomes a machine, a crop, a chemistry problem, and a shared resource all at once. Humans breathe in oxygen and breathe out carbon dioxide. Too little oxygen and the body begins to fail. Too much carbon dioxide and the mind becomes confused before the danger is even fully understood. On a short mission, machines can scrub carbon dioxide and tanks can store oxygen. On a long mission, lasting centuries, that is not enough. A generation ship needs a breathing system, that behaves more like a planet than a spacecraft. Plants, algae, microbes, and chemical systems would all need to work together. The carbon dioxide from human breath could feed photosynthetic life. Plants could release oxygen. Waste could be broken down and returned as nutrients. Water could carry minerals back into growing systems. In the best version, the ship becomes a closed loop where almost nothing is truly thrown away because there is nowhere away for it to go. But closed loops are difficult. Earth's biosphere works because it is enormous, ancient, diverse, and buffered by oceans, forests, soils, weather, and countless living systems interacting in ways we still do not fully understand. A generation ship would be a tiny artificial version of that, built by engineers who must decide in advance what balance of organisms, machines, chemicals, and human behavior will remain stable over time. If the algae grows too fast, chemistry changes. If the soil microbes shift, oxygen may be consumed in unexpected ways. If a crop disease spreads, food and air systems can both be affected. If the human population changes too much, the balance of oxygen demand and food production changes with it. The terrifying part is not that these problems are impossible. The terrifying part is that they are alive. A reactor follows physics. A pipe follows pressure. But an ecosystem responds. It adapts, it shifts, it creates feedback loops. It can surprise the people who built it. And on a generation ship, surprises cannot simply be studied from. The experiment contains the entire population. If the air system becomes unstable, everyone is inside the problem. Water is similar, but more immediate. A human being can survive much longer without food than without water. On a generation ship, water would be recycled again and again. The moisture in breath, sweat, washing, urine, cooking, plant growth, and waste processing would all have to be recovered. Ideally, the same water molecules would move through people, pipes, filters, plants, tanks, and back again for centuries. This is possible in principle. We already recycle water in space. But a generation ship cannot depend on regular replacement parts from Earth. Filters degrade, membranes clog, pumps fail, pipes corrode, sensors drift out of calibration. Microbial films grow where they should not. A tiny leak that would be annoying on Earth becomes serious if it continues unnoticed for years. The ship must carry reserves, but reserves are not infinite. More importantly, it must carry the ability to repair the system that protects the reserves. The true danger is not one dramatic failure. It is gradual loss, 1% less efficiency here, a small contamination issue there, a pump replaced with an imperfect copy, a maintenance schedule delayed because another crisis feels more urgent. Over decades, the margin shrinks, and a generation ship survives, not because nothing ever goes wrong, but because it always has margin left when something does. That may be the first real answer to the question of how long humans could survive inside a generation ship. They survive as long as their margins survive, as long as there is extra power, extra water, extra food, extra parts, extra knowledge, extra trust, and extra time to respond before a problem becomes fatal. A ship with no margin is not surviving. It is only waiting for the first event it cannot absorb. And deep space will eventually provide that event. Not because space is malicious. It is not. Space is indifferent. It does not attack the ship with intention. It simply remains what it is: cold, vast, dark, radioactive, and empty enough that help is impossible, but not empty enough to be safe. Particles strike. Materials age, systems drift, people disagree, children grow into adults with questions their grandparents may not want to answer, and the ship keeps moving, year after year, through a darkness so large that even after generations of travel, the destination may still look like a bright star and nothing more. This is why the generation ship is such a powerful idea. It forces us to see interstellar travel not as an adventure, but as endurance, not as a launch, but as inheritance, not as a machine crossing space, but as a civilization trying to remain alive long enough for distance to become a rival. And once the ship has power, air, and water, the next question becomes even more personal. What does it eat? Because every person aboard, every child, every worker, every teacher, every doctor, every engineer, every elder looking back on a life spent entirely inside the walls of the ship needs food every day. Not once, not only during emergencies, every day, for centuries. And unlike power or air, food is not just survival. Food is culture. Memory, comfort, health, routine, a meal can hold a society together in quiet ways that machines never can. But in deep space, every calorie has to be made inside the ship. And that is where the next layer of the problem begins. In deep space, food becomes one of the most delicate forms of engineering. It is easy to imagine a generation ship as a vessel filled with futuristic machines, quiet corridors, glowing control rooms, and enormous engines pushing humanity toward another star. But beneath all of that, beneath the dream and the metal and the mathematics, there is a simpler truth. Every person aboard will need to eat every day for their entire life, and every bite will have to come from somewhere inside. There are no fields outside, no oceans to fish from, no forests to gather from, no supermarkets, no imports, no emergency harvest from another world. If the ship is 300 years away from its destination, and the food system begins to fail in year 80, the problem is not temporary. It is not a shortage that can be solved by waiting for help. It is a threat to the entire future of the mission. So a generation ship cannot simply store food. Stored food can help at the beginning. It can act as a reserve. It can protect the population during emergencies, crop failures, disease outbreaks, or repairs to agricultural systems. But stored food runs out. It also degrades over time. Vitamins break down. Packaging fails. Flavors change. Nutritional quality falls. A ship designed to last for centuries cannot survive on supplies packed at launch. It must grow its own food again and again, with enough reliability that eating becomes normal, not a daily reminder of how close everyone is to collapse. The most obvious answer is agriculture. But agriculture in space is not agriculture as we know it on Earth. On Earth, farming rests on an entire planet. Sunlight comes freely from above. Soil is built by living systems over thousands of years. Rain falls. Insects pollinate. Wind moves pollen and moisture. Microbes break down dead matter. Seasons give rhythm to planting and harvesting. Even when farmers use advanced technology, the farm is still supported by a vast natural system that existed long before humans arrived. On a generation ship, all of that has to be recreated, controlled, or replaced. The ship would likely need large growing areas, divided across multiple decks or rotating habitats. Some crops would be grown hydroponically, with roots suspended in nutrient-rich. Others might grow aeroponically, with roots misted by carefully measured nutrient solutions. These systems save space and water. They allow engineers to control exactly what plants receive. They can be stacked vertically under artificial light. They can produce food efficiently in places where normal soil farming would be impossible. But efficiency is not the same as resilience. A perfectly optimized system can be fragile. If every crop depends on the same nutrient supply, the same lighting schedule, the same pumps, and the same sensors, then one failure can affect everything. A small error in water chemistry could spread through the entire food chain. A disease could move quickly through plants grown in close quarters. A single overlooked weakness could become a ship-wide emergency. That is why a generation ship would need diversity. Not only one crop, but many. Not only one method, but several. Grains for calories, potatoes or other root crops for reliable energy, legumes for protein, leafy greens for vitamins, fruits where possible, not only for nutrition but for morale, algae for oxygen and food supplements, fungi for recycling organic matter, perhaps insects, fish or small animals if the ship can support them efficiently. Every layer would have to connect with the others, so that waste from one system becomes fuel for another. Nothing can truly be thrown away. On Earth, waste disappears from our daily attention, but it does not disappear from the planet. It enters soil, water, air, bacteria, oceans, and chemical cycles. A generation ship would need to make that reality visible. Food scraps, plant stems, human waste, dead leaves, expired materials, all of it would become part of the recycling system. The ship would have to transform waste back into nutrients, nutrients back into crops, crops back into meals, and meals back into human. That loop sounds beautiful when described from a distance. In practice, it is uncomfortable, complicated, and absolutely necessary. Because a generation ship is not a place where purity can be imagined in the same way. Everything is reused. The water someone drinks today may have passed through plants, machines, pipes, bodies, filters, and tanks many times before. The nutrients feeding tomorrow's vegetables may have come from the waste of yesterday's meal. This is not a flaw in the system. It is the system. A ship that cannot accept recycling at the deepest level cannot survive long enough to cross the space between stars. And yet food is not only chemistry, it is emotion. People do not eat only to keep their cells alive. They eat to remember, to gather, to celebrate, to comfort themselves, to mark days, to feel that life is more than maintenance. A population trapped inside a ship for generations would need meals that feel human. If every day becomes the same grey ration, if food becomes only a calculated paste of calories and vitamins, the body may survive while the spirit of the society begins to weaken. This matters more than it sounds. A ship society would already be carrying enormous psychological pressure. No open horizon, no natural weather, no private escape from the larger mission, no true wilderness, no casual possibility of leaving everything behind and beginning again somewhere else. Under that pressure, ordinary rituals become important. Shared meals, seasonal festivals created by the ship's own calendar, special foods grown for rare occasions, recipes passed down from the first generation, a taste of earth preserved not because it is efficient, but because it gives people a sense that their lives contain continuity. A generation ship must feed bodies, but it must also feed memory. The same is true for medicine. At launch, the ship might carry brilliant doctors, surgeons, nurses, pharmacists, dentists, psychologists, and biologists. It might carry operating rooms, diagnostic scanners, surgical tools, medicines, vaccines, antibiotics, and genetic databases. It might begin as one of the most carefully prepared medical environments ever built. But time changes that. Doctors age, specialists die, medicines expire. Tools wear down. Machines need calibration. New diseases can appear inside a closed population, not necessarily from alien microbes, but from ordinary human biology changing over time. Bacteria evolve, viruses mutate, immune systems shift in a controlled environment. Injuries happen, births happen, mental illness happens, cancer happens, dental infections happen, accidents happen. A generation ship cannot assume that because the mission is planned, life will be orderly. The medical system has to be self-contained in a way no hospital on Earth truly is. On Earth, even a large hospital depends on outside supply chains, universities, equipment manufacturers, laboratories, blood banks, pharmaceutical factories, specialist networks, and emergency transfers. If a case is too complex, another hospital may help. If a medicine is unavailable, it can be ordered. If a machine breaks, a manufacturer can send parts. If a specialist is needed, one can be called. Inside a generation ship, there is nowhere else. This means medicine aboard the ship would have to be broad rather than narrow. Every doctor may need to understand many fields. Every nurse may need emergency skills. Every generation must train the next before the older experts disappear. The ship cannot afford to have only one person who understands a critical procedure. It cannot afford knowledge trapped in one mind. If that person dies unexpectedly, an entire medical capability could vanish with them. The ship would also need to manufacture medicines. Not every drug can be stored for centuries. Some might be synthesized from chemical feedstock. Others might be produced biologically, using engineered microbes or controlled laboratory systems. Antibiotics, hormones, painkillers, anesthetics, vaccines, and emergency treatments would all need production pathways that can be maintained without Earth. This turns medicine into another branch of manufacturing. The doctor does not only treat the patient. The society must preserve the ability to create the tools of treatment. And manufacturing may be one of the least glamorous, but most decisive parts of the entire generation ship problem. A ship that cannot make what it needs is already dying. It may take a long time. The decline may be invisible at first. But every machine has parts. Every part has a lifespan. Seals become brittle. Bearings wear down. Wires degrade. Screens fail. Filters clog. Pumps lose efficiency. Valves stick. Bolts strip. Fabrics tear. Radiation damages electronics. Micrometeoroid impacts scar outer layers. Even the machines used to repair machines will eventually need repair themselves. For the first years, spare parts may be enough. The ship launches with storage rooms full of replacements. Every important system has backups. Every backup has components waiting in inventory. But over decades and centuries, storage becomes less comforting. A part taken from storage is one less part remaining. A tool that breaks while making a replacement creates a deeper problem. Raw materials must be tracked, recycled, refined, and reshaped. Metals, plastics, glass, ceramics, fibers, electronic components, medical materials, agricultural equipment, all must be within the ship's industrial reach. This means the generation ship is not only a home and a farm, it is a factory. But not a factory in the simple sense of assembly lines making identical products. It needs flexible manufacturing. It needs workshops that can produce rare parts when rare parts fail. It needs people who can design replacements when original components no longer exist. It needs printers, mills, chemical processors, furnaces, clean rooms, recycling plants, testing labs, and quality control systems. It needs the ability to take something broken, understand what it was supposed to do, recover the material if possible, and create something that can do the job again. This is where the word survive becomes more complicated. A person survives by breathing, drinking, and eating. A ship survives by repairing itself. A civilization survives by remembering how. If manufacturing knowledge declines, the danger may not appear immediately. The ship might continue operating for years on stored components and inherited procedures. But then a part fails in a way nobody has seen before. The original engineers are long gone. The design files exist, but the material used in the original version is no longer available in the same purity. The fabrication machine can make something close, but not exact. The young engineer standing there has to decide whether close is good enough. In that moment, the future of the ship may depend on education that began decades earlier. That is why schools aboard a generation ship would not be ordinary schools. They would not exist only to help children find careers. They would exist to preserve the mission's ability to continue. Children would grow up learning that knowledge is not just personal achievement, it is life support. Mathematics is not abstract. It is navigation, engineering, medicine, agriculture, and power. Biology is not only a subject. It is air, food, disease, birth, death, and ecological balance. History is not only memory. It is the record of mistakes that must not be repeated. But this creates a difficult emotional burden. How much freedom can children have in a place where the society needs certain skills to survive? What if not enough young people want to become engineers? What if a generation grows tired of training for systems they did not choose to inherit? What if they want art, music, philosophy, games, love, and ordinary life more than another maintenance shift in the water recycling deck? A healthy ship society cannot treat people like replaceable components. If it does, resentment will grow. But it also cannot ignore the fact that some jobs must be done. Air systems do not care whether anyone feels inspired. Reactors do not care whether a generation is tired. Crops do not wait for motivation. The ship's culture would have to find a balance between duty and life, between survival and freedom, between the needs of the mission and the needs of the people who never volunteered for it. This balance may be one of the most fragile systems aboard. Too much control, and the ship becomes a prison with engines. Too much freedom without responsibility, and critical systems may be neglected. The best version would need a culture where service to the ship feels meaningful, respected, and shared, not forced onto the unlucky. A child who becomes a water engineer should not feel condemned to pipes. They should feel that they are one of the people who keeps the world alive. A farmer should not feel trapped in an agricultural deck. They should feel that they are growing the future. A doctor should not feel like the last defense against inevitable decline, but part of a chain of care stretching across generations. Meaning is not decoration on a generation ship. Meaning is infrastructure. Without it, people may continue working for a while. They may follow rules because the rules exist. They may repeat rituals because their parents did, but over time, if the reason behind those actions fades, obedience becomes fragile. The mission becomes something imposed rather than something carried. And once enough people feel that difference, the ship's greatest danger may no longer be technical. It may be social. Because after food, medicine, and manufacturing, the next question is not whether the ship can keep human bodies alive. The next question is whether it can keep a human community from slowly breaking apart. A generation ship could have breathable air, clean water, functioning farms, working reactors, and enough spare parts to last for centuries. It could still fail if the people inside lose trust, if they stop believing the system is fair. If conflicts accumulate without resolution, if one group feels it carries more burden than another, if children grow into adults who look at the mission and quietly ask why the choices of the dead should rule the lives of the living, that question cannot be repaired with a tool. It cannot be solved with a backup pump or a better crop yield. It belongs to the human side of the generation ship, the side that may prove harder than all the machines combined, because in the end, the ship is not really sealed by metal. It is sealed by dependence. Everyone depends on everyone else. The farmer depends on the engineer. The engineer depends on the doctor. The doctor depends on the teacher. The teacher depends on the people who maintain air, water, power, and order. No one survives alone. No one can step outside the system. And in a world where leaving is impossible, relationships become as important as oxygen. This is where the generation ship stops being only a spacecraft. It becomes a test of whether human beings can build a society small enough to fit inside a vessel, but strong enough to last longer than anyone who started it. And that is where the most dangerous problems begin. The most dangerous part of a generation ship may not be the reactor or the water system or the distance to the nearest star. It may be the simple fact that nobody can leave. On Earth, human societies are always shaped by movement. People move away from families. They leave cities. They change jobs. They escape bad relations. They start over. They search for places that fit them better. Even when life is difficult, the possibility of distance changes everything. It gives conflict a release valve. It gives the unhappy a direction. It gives the restless somewhere to go. Inside a generation ship, that option disappears. There is no other city, no other country, no open road, no wilderness, no sea, no second sky, waiting somewhere beyond the walls. If two people hate each other, they may still pass each other in the same corridor for decades. If two families carry an old resentment, their children may inherit it without ever understanding where it began. If a group feels ignored, mistreated, or trapped, there is no border they can cross to build a separate life. The ship is the whole world, and the whole world is sealed. That changes the meaning of every disagreement. A small conflict on Earth can remain small because people have space around it. A small conflict inside a closed ship can echo. It can become part of the atmosphere. It can move from a private argument into a family story, then into a social division, then into something older and heavier than the people currently alive. And because the population is limited, no one is ever truly anonymous. Everyone's choices matter. Everyone's reputation follows them. Everyone belongs to a network of dependence. This is why governance would be as important as engineering. A generation ship cannot simply have rules. It needs legitimacy. It needs people to believe that decisions are made fairly, that burdens are shared, that leaders can be questioned, that mistakes can be corrected, and that no group has quietly taken control of the future. If that belief disappears, the ship may continue functioning for a time, but the society inside it begins to weaken. The first generation might accept strict rules because they remember the launch. They know why the ship exists. They helped create the mission, or at least chose to join it. They understand the sacrifice because they made it with open eyes. But their children are different. They did not vote to leave Earth. They did not stand under the last blue sky and choose the void. They woke into the mission as reality. Their entire life was decided before they existed. At first, this may not create rebellion. Children accept the world they are born into because they have nothing else to compare it with. To them, the ship is normal. The hum of ventilation, the rhythm of artificial light, the careful use of water, the lessons about systems, the stories of Earth, the long direction toward another star. All of it becomes the background of childhood. But as they grow older, the question may begin to form. Why are we doing this? Not as curiosity, as pressure. Why must we continue toward a destination no one alive has seen? Why must our lives be organized around a promise made generations ago? Why should the dead have authority over the living? Why should a person born in year 100 obey a mission charter written by people who never knew them? These questions are not childish. They are not selfish. They are serious moral questions. And a generation ship that cannot answer them honestly is in danger. The answer cannot simply be, because the mission must continue. That may be true from the perspective of survival and purpose, but it is not enough for a society of thinking people. The ship must give each generation a real voice. It must allow the living to shape the conditions of their own lives. It must be able to change without destroying itself. It must protect the mission while not turning the mission into a cage. This is extremely difficult. If everything can be changed by vote, then one frustrated generation might decide to abandon the destination, alter the social structure, reduce training requirements, or redirect resources away from long-term survival towards short-term comfort. But if nothing can be changed, the ship becomes authoritarian by design. It asks people to obey ancestors forever. That kind of system may remain orderly on the surface, but underneath it creates resentment, secrecy, and eventually resistance. The best version would need something more delicate, a core set of principles that cannot be easily broken. The protection of life support, the preservation of knowledge, the basic rights of every person aboard, the duty to maintain the ship, and the responsibility to keep future generations alive. Around that core, everything else must be allowed to evolve. Laws, schedules, leadership structures, education methods, cultural practices, even the meaning of the mission itself may need room to change. Because time changes people, and a generation ship is made of time. The society inside would need courts, councils, mediators, teachers, historians, engineers, doctors, and ordinary citizens who trust the process enough to use it before anger becomes fracture. It would need rituals for disagreement, not just ceremonies of unity, but ways to argue safely, ways to say no, ways to challenge power without being treated as a threat to survival. In a closed world, suppressing conflict is not the same as solving it. Suppressed conflict does not vanish. It waits. And if it waits for generations, it becomes part of the ship's hidden structure. Imagine a disagreement over water use. At first, it is technical. Agricultural decks request more water for a difficult crop cycle. Residential sections are told to reduce personal consumption. Engineers warn that reserves are slightly lower than expected. The leadership makes a decision. One group sacrifices more than another. Perhaps the decision is reasonable. Perhaps it is even necessary. But if the people affected feel unheard, the memory remains. Years later, another shortage happens. The same group is asked to sacrifice again. The old memory, people begin saying that the system always protects some sections more than others. Maybe the claim is exaggerated. Maybe it is true. Either way, trust has been damaged. And trust, like oxygen, must be constantly renewed. A generation ship cannot survive on perfect agreement. That will never exist. It survives on the belief that disagreement can be handled without tearing the world apart. the psychological side is just as difficult. Human beings evolved in environments filled with variation. Open skies, changing weather, natural light, unplanned sounds, smells from soil, rain, plants, animals, oceans, fire, spaces where the eye can look far into the distance, moments of solitude where no wall is close. A generation ship may try to recreate some of this, especially if it is large enough to contain parks, artificial landscapes, water, trees, and rotating habitats with a sense of open space. But everyone aboard still knows the truth. The sky is engineered, the weather is managed, the horizon curves because the world is a machine. For the first generation, that knowledge may feel sharp. They remember the real thing. They know what has been lost. For later generations, it may be less painful, but it becomes something else, an invisible boundary around imagination. A child born inside the ship may dream of Earth from old recordings, but they cannot truly know what it means to stand under a sky that has no ceiling. They cannot know the feeling of walking in a direction without eventually meeting a wall. They cannot know weather that no one scheduled. This does not mean they cannot be happy. Humans are adaptable. A ship-born child may love the gardens, the corridors, the observation decks, the hum of the engines, the community festivals, the stars through thick glass. They may feel at home in ways the founding generation never could, but their minds would still be shaped by enclosure. Their sense of normal life would be built inside limits. Those limits could create stability, or they could create a quiet ache that no one knows how to name. Over time, the ship would need to provide more than survival. It would need art, music, stories, games, spiritual life, humor, privacy, beauty, and wonder. These are not luxuries. They are part of keeping people psychologically alive. A society that only maintains systems and counts resources may survive biologically while becoming emotionally exhausted. People need reasons to wake up that are not only duty. They need moments where life feels like more than being useful to the machine. This is where culture becomes life support. The ship would need songs that belong to the voyage, stories of the launch, but also stories of those born later, holidays that mark not only Earth memories, but ship events, the first successful harvest after a crisis, the first child born in interstellar space, the day Earth's signal became too faint to hear clearly, the midpoint of the first visible brightening of the destination star. These moments would help people feel that they are not merely trapped between two worlds, but living inside a history of their own. Without culture, the mission becomes maintenance. With culture, the mission becomes identity. But identity can also divide. Some people may see themselves as descendants of Earth, guardians of humanity's original dream. Others may begin to see themselves as something new, a ship-born people whose loyalty is not to a planet they never knew, but to the vessel itself. Some may believe the destination is sacred. Others may believe arrival is dangerous, unnecessary, or even a betrayal of the only world they have. If the ship has traveled for centuries, there may be people who do not want to leave it at all. That is a strange possibility, but a realistic one. For people born aboard, the ship is not a vehicle. It is home. The destination planet, even if beautiful, is the unknown. It has uncontrolled weather, open space, unfamiliar gravity, unknown microbes, wild landscapes, and dangers no one has lived with before. The ship, for all its limits, is known. It is controlled. It is ancestral. People are buried there or remembered there. Families have histories in specific sections. Children know the sound of certain doors, the smell of certain gardens, the view from certain observation windows. To leave the ship may feel to them the way leaving Earth felt to the first generation. So even success creates conflict. After generations of sacrifice, the ship may arrive at another star and discover that not everyone wants to descend. Some may want to settle the planet. Some may want to remain in orbit. Some may want the ship preserved as the true homeland. Some may argue that the destination is too risky. Others may say that refusing to land betrays everyone who lived and died to reach it. That decision would carry centuries of emotion, and it would be made by people who inherited both the mission and the burden of completing it. Before arrival, however, the ship must survive another quiet threat: population balance. A society in a sealed world cannot grow without limit. Every additional person needs air, water, food, space, education, medical care, and future, but the population also cannot fall too low. Too few people means too little labor, too few specialists, too little genetic diversity, and too much risk if disease or accident strikes. The ship has to maintain a narrow path between overcrowding and decline. This makes birth not only a private event, but a public concern. That is one of the most uncomfortable truths of a generation ship. On Earth, reproduction is deeply personal, shaped by love, family, culture, and individual choice. Inside a ship, the number of births affects everyone. Too many births could strain food and water systems. Too few could weaken the future workforce or reduce genetic health. A long-term population plan would be necessary, but any system that controls family life too tightly risks becoming oppressive. Again, the ship must balance freedom and survival. It may use incentives instead of force. It may plan education and housing around expected population cycles. It may preserve frozen genetic material to protect diversity. It may encourage certain timing of births without dictating every family decision. But no matter how carefully it is handled, the fact remains, in a closed world, private choices have public consequences more directly than they do on Earth. This can bring people together because everyone understands the shared stakes. Or it can create resentment because people may feel that even the most intimate parts of life belong to the mission. A generation ship, then, is not only a test of technology, it is a test of consent across time. The first generation consents, the second inherits, the third adapts, the fourth may question, the fifth may redefine. And somewhere far from Earth, long after the original voices are gone, the ship must still persuade its people that survival, duty, and hope belong together. Not by force, not by fear, not only by tradition, but by making life inside the ship worth living. Because if life becomes only endurance, the mission will rot from within. People can endure hardship when hardship has meaning. They can accept limits when they trust the reason. They can sacrifice when they feel that sacrifice is shared and remembered. But if the ship becomes a place where people feel used by a purpose they did not choose, then every system, no matter how advanced, is built on unstable ground. The question then is not simply how long the ship can keep humans alive. It is how long humans can keep believing in the ship. And beyond the social walls of that fragile world, deep space is still waiting. Radiation passes silently through shielding. Dust grains strike at impossible speeds. Materials age. The darkness outside remains patient. Even if the people remain united, even if the farms keep growing and the reactors keep burning, the universe itself continues to press against the hull. That pressure is the next problem. Because a generation ship is not crossing empty space. It is crossing an environment that can slowly damage everything it touches. Deep space looks empty because almost everything inside it is too small, too dark, or too spread out for the human eye to notice. From a window, it would seem peaceful. A black ocean filled with distant points of light. No storms, no mountains, no waves, no visible danger moving toward the ship. But emptiness is not the same as safety. A generation ship would travel through an environment that is almost silent, almost still, and almost impossible to escape. It would not face danger every second in a dramatic way. Most days would pass normally. People would wake, work, eat, study, repair, argue, rest, and sleep. Children would grow. Crops would be harvested. Lessons would be taught. The ship would move forward through the dark. And all the while, space would be wearing it down. The first threat is radiation. On Earth, we live under protection so constant that we forget it exists. The atmosphere above us absorbs and scatters dangerous particles. The magnetic field of the planet bends charged particles. Rock, air, water, weather, and distance all stand between our bodies and the harsher parts of space. We are not simply living on a planet, we are living inside a shield. A generation ship leaving the solar system loses that shield. Beyond Earth, beyond the protection of a planetary magnetic field, high-energy particles move through space at nearly the speed of light. Some come from the sun during powerful eruptions. Others come from far beyond the solar system, accelerated by violent events across the galaxy. Supernova remnants, active regions around massive stars, and other extreme cosmic processes can launch particles with enough energy to pass through ordinary spacecraft walls, as if the walls were barely there. For a short mission, radiation exposure is a risk to be managed. For a generation ship, it becomes a permanent condition of life. The ship cannot simply hide from radiation for a few days and wait for the danger to pass. It must live inside that reality for decades or centuries. Shielding becomes part of architecture. Water tanks may be placed around living areas because water is useful against certain kinds of radiation. Storage materials, fuel, waste reservoir, and even agricultural mass could be arranged to protect the most inhabited sections. The safest rooms might be buried deep inside the ship, surrounded by layers of material. During periods of higher radiation, people might move into protected shelters until the danger lowers. But shielding has a price. Mass is expensive in space. Every ton added to the ship must be accelerated. Every extra layer of protection requires more energy to move across interstellar distance. A ship with too little shielding risks the health of its population. A ship with too much shielding may become so heavy that the journey becomes impossible. The design must balance survival against movement, protection against speed, and even with good shielding, some radiation gets. That means the ship's medical system would have to watch for long-term effects across generations. It would need to track cancer risks, fertility, immune changes, genetic damage, neurological effects, and subtle shifts in health that may not appear immediately. The danger is not only one person becoming sick. The danger is the population slowly changing under a pressure that never fully stops. The ship would need medical records lasting centuries, not as archives, but as active survival tool. A disease trend that looks small in 1 decade may become serious after 5. That is one of the great difficulties of a generation ship. Many dangers do not announce themselves with alarms. They become visible only through patterns. A little more illness, a little less fertility, a small rise in complications, a subtle change in childhood development, a few more memory problems among workers who maintain complex systems. None of these alone may seem like the end. Together, over time, they can bend the future. Radiation is not the only thing outside. There is dust. This sounds harmless until speed is added. A grain of dust floating in space is almost nothing. But if a ship is moving at a meaningful fraction of light speed, even tiny particles become dangerous. A small object striking the hull at extreme velocity can release enormous energy into a very small area. Most impacts may be absorbed by outer shielding. Some may leave scars. Some may damage sensors, radiators, antennas, or protective layers. Over 1 year, the damage may be manageable. Over 200 years, the ship becomes a target for countless invisible strikes. The solution is not one thick wall. It is layers. Outer shields can break apart incoming particles before they reach the main hull. Gaps between layers allow the impact energy to spread. Sacrificial surfaces can be designed to take damage and be replaced. Sensitive areas can be placed behind deeper protection. The front of the ship, facing the direction of travel, may need the heaviest shielding of all, because it meets the interstellar medium head-on. But again, nothing is permanent. Outer layers erode, small cracks form. Materials become brittle. Heat cycles expand and contract surfaces. Radiation weakens structures. Impacts create invisible stress. A generation ship must inspect itself constantly. It needs sensors in the hull, repair robots, exterior maintenance systems, and crews trained to understand damage that may have been accumulating since before they were born. Repairing the outside of a generation ship would be one of the most difficult and dangerous jobs in human history. The workers would not be stepping outside near Earth, with home below them and rescue possible. They would be outside a moving world in deep space, surrounded by darkness, with their entire civilization behind one wall. Every tool, every tether, every procedure would matter. A mistake would not only risk one worker, it could risk a section of the ship. This is why the ship's design must avoid needing heroism. A society cannot survive for centuries if survival depends on rare acts of bravery every time something breaks. The systems must be repairable in ordinary ways by trained people doing careful work. Heroic moments may still happen, but they cannot be the plan. Must be redundancy. Redundancy means no single failure is allowed to become the end. If one air processor fails, another takes over. If one crop system is damaged, others compensate. If one reactor goes offline, power can be reduced but not lost. If one school loses a teacher, others carry the knowledge. If one section of the hull is damaged, doors seal, pressure is contained, and repairs begin before the whole ship is threatened. Redundancy is easy to say and hard to afford. Every backup takes space. Every extra system needs materials. Every spare part must be stored or manufactured. Every duplicate system adds complexity. But without redundancy, a generation ship is too fragile. A single point failure on Earth can be tragic. A single point failure in interstellar space can erase centuries of planning. The ship must also know where it is. Navigation seems simple when we imagine a line drawn from Earth to another star. But space is not a flat map. Stars move. The ship moves. Its target moves. The observations made before launch become older every year. A tiny error in course can grow into a huge miss over interstellar distances. If the ship travels for a century and discovers too late that its path is slightly wrong, correcting that mistake may require enormous energy. There is no GPS between stars. The ship would navigate by measuring the positions of stars, pulsars, and other celestial references. It would compare what it sees to what its models predict. It would use onboard telescopes, sensors, and computers to understand its location and velocity. It would need to make small corrections long before small errors become large ones. And the people responsible for this must be as competent in year 200 as the original navigation team was in year 1. Navigation is not only technical, it is psychological. A population living for generations inside a ship must trust that the ship is still going where it is supposed to go. They may not feel motion. They may not see the destination change in any meaningful way for most of their lives. The stars outside may look almost frozen. The journey may feel more like a belief than an experience. That creates a strange kind of pressure. People are asked to maintain a mission whose progress is almost invisible. The ship may be traveling at extraordinary speed, but human senses cannot feel that speed in the middle of deep space. There is no road rushing beneath them, no wind, no changing landscape, only calculations, instruments, and faith in the systems. A generation could be born, live, and die, while the destination remains nothing more than a brighter point in the forward sky. This is why records matter. The ship would need to show its people the journey in ways they can understand emotionally. Maps of progress, visualizations of distance crossed, records of how the sun has faded behind them, images of the target star slowly becoming brighter across decades. The people aboard need to feel that their lives are part of movement, not just confinement. Communication with Earth would help at first. In the early years, the ship could still receive messages. There would be delays, but Earth would remain present. Families left behind could send recordings. Scientists could send updates. Artists could send music. Children born aboard could hear voices from the planet their parents left. News would arrive late, but it would arrive. Earth would still feel like a living place. Then the delay grows. A message takes months, then years. A question sent to Earth may not receive an answer until the situation has already changed. The ship can no longer depend on Earth for decisions, advice, or comfort in any immediate sense. Communication becomes less like conversation and more like archaeology. Messages from Earth arrive as pieces of a past that has already moved on. Eventually, the signal may become weak, rare, or impossible to maintain. There may not be one final goodbye. Instead, Earth fades. Transmissions become harder to receive. The gaps grow longer. The information becomes older. The voices become memories. The ship's community may hold ceremonies around the last clear message from home, not because the message itself solves anything, but because losing contact with Earth would be a profound emotional event. After that, the generation ship is no longer a mission sent by a planet. It is an independent human world. That independence is both freedom and loneliness. The people aboard cannot wait for permission. They cannot ask Earth to settle arguments. They cannot rely on new discoveries arriving in time to save. They must become complete enough to decide for themselves. Their science, law, medicine, engineering, education, and culture must all stand on their own. And the ship's computers, however advanced, cannot carry that burden alone. Artificial intelligence may help. It could monitor systems, detect patterns, teach students, assist doctors, model ecosystems, guide repairs, and preserve vast libraries of human knowledge. It could be one of the most important tools aboard. But the ship cannot become helpless without it. Software can fail. Hardware can degrade. Data can corrupt. Systems can make mistakes. A society that forgets how to think because machines think for it has created another single point of failure. The strongest version of a generation ship uses automation without surrendering understanding. People must still know how to reason. They must still practice manual skills. They must still question outputs, test assumptions, and repair the tools that guide them. The ship needs intelligence distributed through people, institutions, machines, and culture, not one brain. This returns to the deepest theme of the journey. Survival is not one system. It is the connection between systems. Radiation affects health. Health affects population. Population affects labor. Labor affects maintenance. Maintenance affects power. Power affects food. Food affects morale. Morale affects cooperation. Cooperation affects governance. Governance affects whether people continue doing the difficult work that keeps the ship alive. Nothing is separate. A generation ship is a web, and every part pulls on every other part. That is why the true danger is cascade failure. A crop disease reduces food production. Rations are tightened. People become stressed. Arguments increase. Maintenance teams are distracted. A water pump repair is delayed. Water quality drops. Medical problems rise. Trust in leadership weakens. Some people accuse others of hiding resources. Security becomes stricter. Resentment grows. Schools lose focus. Training quality falls. Years later, a technical problem appears, and the people responsible are less prepared than they should have been. The original cause was one agricultural failure. The final danger may appear somewhere completely different. This is how complex systems break. Not always through one explosion, one error, or one obvious enemy. They break through connections, through stress moving from one system into another, until the whole structure is carrying more weight than it was designed to bear. A successful generation ship must be built around the assumption that failures will happen. Not maybe, not rarely. Certainly crops will fail. People will make mistakes. Machines will break. Leaders will disappoint. Children will question. Systems will drift. The ship survives only if it can absorb failure without becoming defined by it. That requires reserves, but also humility. The founders cannot design every answer. They cannot predict every crisis. They cannot know the exact needs of the seventh generation, or the emotional world of children born halfway between stars. They can only build a ship and a society flexible enough to keep learning. A rigid generation ship may feel strong at launch, but over centuries, rigidity becomes weak. The mission needs structure, but it also needs adaptation. And if it adapts well enough, if it preserves knowledge, protects health, repairs damage, manages conflict, keeps its ecosystem stable, and gives its people a reason to continue, then one day the destination will begin to change. For most of the voyage, the target star is only a point. Then, slowly, it becomes the brightest point. Then, instruments begin to resolve more detail. The ship detects planets. It studies atmospheres. It measures radiation. It searches for water, temperature, chemistry, clouds, storms, moons, magnetic fields, and signs of danger. The destination stops being an idea and becomes a place. And that may be the most emotional phase of the entire journey, because the people who see it approaching are not the people who left Earth. They are the descendants, the inheritors, the ones who paid the cost of a decision made long ago. They have lived inside the ship their entire lives. They have kept it alive, not for themselves only, but for a promise. Now the promise is becoming visible. But arrival does not mean safety. It means a new set of questions begins. Can the ship slow down? Can it enter the system without missing the target. Is the planet truly habitable, or only almost habitable? Can humans descend? Should they descend? What if the world below is beautiful but dangerous? What if the ship is safer than the planet? What if centuries of travel end not with a new home, but with another impossible decision? That is where the final answer waits. Not in the lawn, not in the middle of the dark, but at the edge of arrival, when humanity finally reaches another star and has to decide whether the journey was survivable after all. Arrival is the part of the generation ship story that sounds like victory, but in reality, it may be the most uncertain moment of all. For centuries, the ship has been moving toward a star that most of its passengers never chose. The first generation saw the mission as departure. The middle generations saw it as inheritance. But the final generations would see something different. They would see the destination becoming real. At first, it would still be only a point of light, brighter than before perhaps, but not yet a place. Then the ship's instruments would begin to separate the star from its planets. A faint wobble in the data, a small shadow crossing the light, a pattern of reflected color. Slowly, the destination system would stop being a promise from old mission archives and become a physical environment with gravity, radiation, orbits, atmospheres, moons, storms, dust, and risk. This is where the ship's long survival turns into a new problem. It is not enough to reach another star. The ship has to slow down. That sounds obvious, but it is one of the hardest parts of the entire journey. A spacecraft moving fast enough to cross interstellar distance in centuries carries enormous speed. If it cannot remove that speed, it will not arrive in any meaningful way. It will simply pass through the destination system, like a bullet through a dark room, seeing the planets for a brief moment before continuing into the void beyond. So the generation ship must carry not only the means to leave, but the means to stop. That may require fuel saved for a final deceleration burn. It may require magnetic sails that interact with the thin material between stars. It may require using the gravity of planets or the destination star to bleed away speed with careful maneuvers. Every option is difficult. Every option depends on systems that must still function after lifetimes of travel. The engines that slow the ship may have been built by people whose names are now historical. The engineers who must use them may know Earth only from recording, and yet the entire mission depends on their ability to make old machinery perform one of the most delicate tasks imaginable. If the deceleration fails, the mission fails. Not because everyone dies immediately, but because the purpose of the journey is lost. The ship may continue onward. It may remain alive for a time. It may even become a wandering world between stars. But the destination, the reason generations preserved knowledge and repaired systems and accepted limits, would slip behind them forever. So the final approach would be filled with tension. Not loud panic, not dramatic alarms every day, but a quiet pressure surrounding everything. Every calculation matters. Every sensor reading matters. Every course correction matters. The ship is no longer crossing the empty middle. It is entering a place where mistakes have shape. And then there is the planet. Before launch, mission planners would have studied the destination world as carefully as possible. They would have looked for signs of atmosphere, temperature, surface conditions, water, radiation levels, and chemical stability. But distance hides details. A planet can look promising from far away and still be impossible up close. Its air may be nearly right, but not right enough. Its surface may contain toxins, Its weather may be violent. Its magnetic field may be weak. Its soil may resist agriculture. Its microbes, if any exist, may be harmless, or they may interact with human biology in ways nobody can predict. The generation ship arrives with hope, but not certainty. The people aboard may look down at a world with clouds, oceans, mountains, deserts, ice, or colors no human eye has ever seen in person. For the first time in centuries, there may be an open sky waiting beneath them. But that sky is not automatically home. A beautiful planet can still kill. A blue ocean can still be chemically hostile. A greenish surface can still hide biology that human immune systems cannot understand. A breathable-looking atmosphere can contain traces that become dangerous after weeks or months. So the ship cannot simply land everyone. It would have to study first. Probes would descend. Drones would map the surface. Laboratories would test air, water, soil, dust, organic material, radiation, pressure, temperature, and microbial behavior. Small teams may eventually go down in sealed suits. They would walk on real ground, perhaps becoming the first humans in generations to feel a planet beneath their feet. But even then, they would not be free. Their suits would protect them. Their air would come from tanks. Their return would depend on vehicles and careful procedures. The first step onto a new world would be less like liberation and more like opening a door very slowly. And for the ship-borne people, even that first step may be psychologically overwhelming. They may have dreamed of planets their whole lives. They may have watched ancient videos of Earth, studied landscapes, oceans, forests, deserts, and sky. But seeing an open horizon is different from learning about one. A real sky has no visible wall. A real wind does not come from a vent. A real storm does not obey a schedule. The natural world is not designed for human comfort. It moves because it is itself. To people born inside a controlled environment, that freedom may feel beautiful and frightening at the same time. Some will want to go down immediately. Some will hesitate. Some may never want to leave the ship at all. And that possibility matters. After centuries, the ship is not only transportation, it is home. It contains family histories, schools, gardens, workshops, old rooms, memorials, songs, rituals, and the ashes or memories of those who never lived to see arrival. Asking people to abandon it for a planet they do not know may feel to them like asking the first generation to abandon Earth. In a strange way, arrival repeats departure. The first passengers left Earth for the ship. Their descendants may have to leave the ship for the planet. Both choices involve grief. Both involve fear. Both involve stepping away from the only world that feels certain. This means the generation ship's success cannot be measured only by whether it reaches the star. It must also survive the emotional shock of completing its own purpose. A society built for travel may struggle to become a society built for settlement. For centuries, every institution aboard has pointed toward keeping the ship alive. Schools, laws, work, culture, and discipline all serve the journey. But after arrival, the question changes. What is the mission now? If the planet is habitable, people must decide how to build, where to settle, how much to depend on the ship, whether to preserve it in orbit, dismantle it for materials, use it as a station, or keep it as a sacred ancestral world. If the planet is only partly habitable, they may need to live between surface habitats and orbital systems for generations more. If the planet is not habitable at all, then the entire community faces a devastating truth. Survival must continue without the reward they expected. That may be the hardest ending, Not destruction, not explosion, not sudden failure, but arrival at a world that is close to right and still not enough. A planet with too much radiation, a planet with the wrong atmosphere, a planet with toxic soil, a planet where farming fails, a planet where humans can visit but not live. In that case, the ship may have to remain the center of civilization indefinitely, orbiting a star it crossed the darkness to reach, close to a world that cannot fully receive it. Would that mean the mission failed? Maybe. Or maybe it would mean the generation ship becomes something else. The seed of a new space-based civilization. A people no longer from Earth, not yet of the planet below, but alive around another star. That may not have been the original dream, but survival often changes dreams. A civilization that can adapt its meaning may endure where a rigid one breaks. So how long could humans survive inside a generation ship? The honest answer is not a clean number. With poor design, only a single major failure in power, water, food, or governance could bring the mission into crisis quickly. With strong engineering but weak culture, perhaps decades, until the first generations of commitment fade and the ship begins to lose direction. With excellent systems, deep reserves, careful population planning, strong education, and a society that knows how to repair both machines and trust, humans might survive for centuries, maybe long enough to reach another star. But survival would never be guaranteed. It would have to be earned continuously. Every year, every generation, every time a child learns why the water system matters, every time a farmer saves a crop cycle, every time an engineer repairs a part that no longer has a replacement, every time leaders choose fairness over control, every time people remember that the ship is not a prison, if the life inside it remains meaningful. A generation ship survives through layers. Power gives it motion and warmth. Air gives it breath. Water gives it continuity. Food gives it strength. Medicine gives it resilience. Manufacturing gives it repair. Education gives it memory. Governance gives it order. Culture gives it purpose. Trust gives it a future. Remove one layer, and the ship becomes weaker. Remove several, and the journey begins to collapse. That is why the generation ship is such a disturbing idea. It reveals that interstellar travel is not really about crossing space. It is about carrying a complete human world through time. Space is vast, but time may be the deeper threat. Time wears down machines. Time weakens memory. Time changes language, beliefs, values, and priorities. Time turns mission statements into old documents. Time turns Earth from a home into a legend. Time asks every generation whether it still believes in what the previous one protected. And if the answer ever becomes no, the ship may still move forward, but the mission inside it has already begun to die. Yet there is also something beautiful here, because a generation ship represents one of the most patient forms of hope imaginable. It is not the hope of instant discovery. It is not the hope of one heroic crew planting a flag under an alien sun. It is the hope of people who know they may never see the ending, but choose to begin anyway. People who plant trees in gardens they will not sit beneath. People who teach children skills for problems that may not appear until after they are gone. People who build for descendants whose faces they will never know. That kind of hope is quiet, but enormous, and in a way we already understand it. Every civilization is a kind of generation ship. Every society depends on those who came before and those who come after. We inherit systems we did not build. We live inside choices made by people who are gone. We pass forward knowledge, damage, beauty, mistakes, tools, stories, and responsibilities. Earth itself is a sealed world in the dark, carrying air, water, soil, life, memory, and billions of fragile human futures around one ordinary star. There is no rescue ship coming for Earth either. No second planet waiting nearby if we ruin the systems that keep us alive. No outside civilization guaranteed to repair what we break. We are already learning the central lesson of the generation ship. Survival is not possession. It is stewardship. It is the art of keeping a world alive long enough for the next generation to inherit it. A real generation ship would make that truth impossible to ignore. Every war would remind its people that life depends on care. Every garden would remind them that nothing grows without balance. Every repair would remind them that neglect accumulates. Every birth would remind them that the future is not an idea. It is a person who will one day ask what kind of world was handed to them. So perhaps the deepest question is not whether humans could survive inside a generation ship. Perhaps the deeper question is whether we can become the kind of species that deserves to. Because crossing the stars would require more than engines. It would require patience, humility, discipline, cooperation, and a willingness to think beyond one lifetime. It would require us to build systems we will not personally benefit from, protect people who do not yet exist, and accept that the greatest achievements may belong not to the ones who begin the journey, but to the ones who continue it after we are gone. A generation ship could survive for centuries, but only if the civilization inside it learns to survive itself. And somewhere in the far future, if such a ship ever leaves the sun behind, it will carry more than humans through the dark. It will carry every question we never solved on Earth. How to share limited resources, how to preserve knowledge, how to live together without escape, how to give meaning to sacrifice, how to care for a world that can break. The stars may be far away, but the hardest distance may not be measured in light years. It may be the distance between what humanity dreams of doing and what humanity must become before the dream can survive the journey. Good night.